Hi and welcome back. In this video, we're going to continue our discussion of creating procedures in Visual Basic. To revisit a few terms that were introduced to us in the previous folder for the course, let's take a look at the term argument versus parameter. Both of these terms are related in that they're all about passing data from one procedure to another. So the basic idea is when you are creating your procedure, you need to figure out, does this procedure need input to do its job? And if so, you'll create a parameter for each piece of data that it should receive. So it's possible that you could create a procedure that has no parameters because it does not require any data, could require one parameter or multiple. Once you create that procedure, then when you call the procedure from, for example, submain, you will need to pass in an argument that corresponds to that parameter. So for every parameter, there will be an argument, and the data types must match up. So we'll take a look at that. First, let's look at a simple example. The example we're looking at is going to ask the user for a customer name and balance, reads them both in. It will echo that information back to the user down here. And notice this is all occurring in submain. We have a few variables, a few prompts. We turn around and display the name and balance as we obtained from the user. But in between time, right here, this is the interesting piece, the piece that's new. We're making a call to a procedure, and I know that because of the parentheses here. Name and address, parentheses. So it is calling a procedure called name and address, and it doesn't, name and address must not require any parameters because notice the empty parentheses here. We have no arguments specified in between the parentheses. So this call to name and address will work correctly if there is a corresponding procedure defined with that same name. So here inside this same module, we have a procedure called name and address. So notice the names, the identifiers of the method or of the procedure match up, and it uses the syntax we explored in the last video. We have the keyword sub followed by the name of the procedure, followed by parentheses. Now, as I said, we were not passing in any arguments to this procedure up here when we called it because the definition of name and address, which is what we're looking at right here, does not require any parameters. And we see that empty parentheses there indicating that. Notice this term method header. Method header refers to the top line of the definition of this procedure. So procedure name and address starts here and goes all the way through the keyword end sub. And presumably both main and name and address are inside of a module that would begin up here at the top and have an end module down below that we just don't see right now. So name and address has its own set of constants. Name and address literally just prints out an address. So presumably this is our business, ABC Manufacturing. We've created three constants, address line 1, 2, and 3, and set them each to their corresponding values of address line 1, 2, and 3. And then very simply, we reference them in the right line. So the steps in and of themselves are not complicated within this procedure, but the key is that we've created a procedure here and we've called it up here. So remember that when a program runs, when it begins, it's always going to start in submain, and up here it would begin by declaring your variables, getting the data. When we reach this line of code name and address, the flow of control shifts and main pauses where it's at, and we jump down here, and the flow of execution is going to execute every line inside of name and address. And when it reaches its conclusion, it will jump back to main and continue on to follow up and write out customer name and balance. So this is just another example of using a sub procedure. This one does not require any parameters. We're going to see an example shortly that does. So some procedures, as we said, they require data to accomplish their tasks. Now, if you were with us last session when we talked about pseudocode in the programming logic class, this corresponds to the last folder, you were introduced to pseudocode that is used to express using these concepts. Now, unfortunately, the pseudocode and the Visual Basic do take a departure at this point. We're going to see some new syntax with Visual Basic that we have not seen before. And the best way to show you that is by example. So the next example that we're going to see in the full in a moment is called even or odd, and it is used to determine whether a number is even or odd. So in order to do that, it does require input. It needs to know what number it's evaluating so that it can do its job. So down here, third from the last bullet point, would be the header of the definition of even or odd. It's a sub-procedure, its name is even or odd, but notice in between parentheses we have one parameter. The parameter name is number, its data type is integer, and byval means that a copy of the argument's value will be passed into this parameter named number. So it looks an awful lot like a variable declaration. So in that way, it is going to be easier, except for instead of the word dim, we're replacing it with the keyword byval. There is another option other than byval, which is called byref. It's not as commonly used, and we'll see an example of that in a future video. So let's take a look at this even or odd example. So again, this example, this cut of code would appear within a module. We have our sub main up here at the top, and we have our even or odd definition, our even or odd procedure down here at the bottom. Let's actually start with even or odd and take a look. It has the familiar mainstays we've seen with the sub and sub, name of the procedure. Again, this whole first line is called the header. But notice in between parentheses, because even or odd needed a input in order to know what it was evaluating to see whether it was even or odd, we needed to create a parameter. So parameter has the syntax either byval or byref. We're going to stick with byval for now. The name of the the name of the parameter, and this is really up to you. It's just like naming a variable. As, and then the data type. So this procedure has one parameter. Now, once you define a parameter, it works like a variable inside of that procedure. So the body of this procedure, even or odd, knows about number and can use it. So it says if number mod 2 equals 0, then we have an even number. And that's because the mod operator takes the remainder of integer division. And we know that all even numbers are evenly divisible by 2, leaving a remainder of 0. So this effectively tests whether we have an even number. And if this is not true, we know we have an odd number. So we just have an if statement in here directing the output to one of two paths. So let's see how it's used. Up here in main, we want to get the number from the user, and here we do so. We know input box is going to return the input as a string, so we assign it to a string variable, and then we convert the string to an integer. So as usual, if we're going to do those steps, we need to have corresponding variables in order to do so. And we call these local variables because they're defined in main. Main knows about them. But any other procedures that we have defined do not have access to these variables. So that was why it was necessary, and why we're going to see momentarily, to define a parameter, because we need to share that data with even or odd. So we get the number, and this particular example is interesting because instead of just asking for a number one time and determining whether it's even or odd, we actually keep asking for numbers and telling the user whether they're even or odd until the user types -999. So this is a classic Sentinel controlled loop. So we initialize the loop control variable number by prompting one time before the loop began. We compare that number to -999. And then the last step in this loop is to get the next number. Those are all the things we always see in Sentinel controlled loops. But in between time, look what we're doing. If the number was not -999, we enter the body of the loop and we call even or odd. So even or odd is being called within the context of a loop. So it calls even or odd, but notice it passes an argument number. So if the user entered 6, for example, the number would hold the value of 6. 6 is what is passed into this parameter down here called number. Now it's very important to understand that they are copied. It is not going to reference the same memory location. It's actually going to take 6 and copy that to this memory location here. They're two different memory locations. This next example kind of drives this point home. It is the exact same example revisited. Everything line by line is exactly the same. The only difference is I renamed my parameter down here NBR for number. If you recall earlier, it was number NUMBER, spelled in exactly the same way up here. So this if run would create the output you see on the right, depending upon, the user's input, of course. It looks like user input 45, then 98, 3, 4, and 5. And then they ended the loop with a -999 because we see that the loop ended. So the program works correctly. It works exactly the same as before, but I renamed this parameter purposefully to illustrate that the name of the variable that is serving as your argument does not need to match up to the name of the parameter. They're passed by position in the list. It's kind of a moot point in this case because there is only one thing in the list. We only have one argument and one parameter. So whatever the user input, for example, their first input was 45, 45 then is copied into NBR. And in the body of procedure even or odd, notice it must refer to the name of the parameter NBR because that is in scope for even or odd. It knows not about number NUMBER. So that is probably one of the most difficult things teaching the course to explain, and I think sometimes it takes a little bit of exposure to these examples for that to become clear. I think our knee jerk is usually to want to have these with the same name, and they certainly can be, but consider that this goes a bit beyond the scope of the class, but you can create libraries with procedures in them that are included in multiple projects. The name of your parameter is hardly ever going to match up to the name of the argument for which you're passing a value in. So right now, all our procedures are defined in the same module, and that's fine. We're getting comfortable with that. But just realize that those names do not need to match up because they are two separate memory locations. So let's go back and take a look at an example I was using in a previous video. This particular program, when run, outputs. This is my example of using a sub procedure and then hello. And if you were with us on our previous video, you saw that the first piece of output came from sub main, but the second piece of output actually came from a procedure called output hello. We invoked, that's also called called. We called output hello here. We know that when we call it, it jumps down and executes the code inside of output hello. So now we can kind of see this example with new eyes. Notice that this procedure takes no parameters. I know that because of the empty parentheses. Therefore, when we call it up here, I also need to have empty parentheses with no arguments within. So output hello is going to create a constant message. And we did that just to show we could define constants and variables inside of our custom procedures we're creating, and then we output it. Okay, but what if I wanted to ask the user for their name, and instead of, just saying hello, I wanted to say hello Gina, or whatever the name is that the user provides. I could do that one time. I could do it in a loop. In the previous video, I showed how we could build a loop to keep displaying the word hello. In this case, I could keep asking for new names. To keep things simple here, though, I'm just going to modify this program to accept an input for the user's name. Now I defined a variable name. It could be defined above or below this statement here. Variable declarations don't necessarily have to be at the top of submain. We usually see them as such. As long as they're declared before they're used, that is the only requirement. We do tend to put them in visible locations so that are easy to find. So I could go ahead and ask my user here, what is your name? Okay, and there's no conversion required here because we're not asking for a number. So I'm just going to assign directly to string variable name. Now, if I want to output the message hello and then that individual's name, I have to pass that information to the procedure output hello. And it so happens that the name that I personally want to pass is what the user just provided. So that is the variable name. Now, as soon as I type that, I get errors. And if you hover over, it says too many arguments. It's saying you're specifying one argument here, but it doesn't match up to the parameter list that says it doesn't receive any information. So I would also have to come down to this procedure, and I will call it name, but again, that particular procedure does not, or parameter does not have to match up to the same identifier as is used in main. However, the data types do. This must be a string if I am passing in a variable of type string, which is what I'm doing here. So now that I have this as a parameter, it's defined inside of this procedure output hello. So I could, maybe I'll modify my constant here and add a space at the end of hello, and then concatenate onto it the name. So now it's going to say hello and greet the user by name. So let's give it a try. So here we get our prompt, what is your name? And there we see our specific message. Now, in general, I don't encourage hard coding values, but I do want to show you, let me comment out some code here for a quick second, that if I had had a string literal, such as Gina, that I wanted to pass, I wanted to make clear that the argument that you pass does not necessarily have to be a reference to a variable. You can also pass in values. So this is what's called a string literal. It represents the text Gina. Because this is a string data type, this will also work as being passed into this parameter. Notice by putting a single quote in front of each one of these lines, this effectively comments out those lines, meaning that when I run this, they will not be executed. So I've simplified the program. It's just going to output hello Gina without the prompt. Again, in general, we would want to make our programs more flexible than this, but I just wanted to demonstrate you can pass in literals. And here we have our Hello Gina. So let's go back and talk about the fact that procedures can have multiple parameters. So that last example, we had one parameter, but often a procedure requires more than one parameter in order to do its job. This is actually quite simple. If you require more than one piece of input, just specify multiple parameters with a comma between each one. When you call that procedure, though, remember that there are multiple parameters defined and you therefore also need to provide multiple arguments. So let's look at this example. I believe we saw this in the programming logic text in pseudocode. Now we're taking a look at it in Visual Basic. So again, we're inside of a module. Let's take a look at the bottom part first. This is our custom procedure we're creating called compute tax. It is a sub-procedure. Notice the parentheses here are part of the definition. And in between the parentheses of this procedure, we see that there are actually two different parameters separated by a comma. So the first parameter, by-val amount as double, creates a parameter called amount as type double. We have a comma and then a second parameter, by-val rate as double. This defines amount and rate to be in scope inside of compute tax so that we can use it down here in a computation that computes and assigns to a variable tax. So notice we did not declare amount and rate, and that's because when you use a parameter, not only does it facilitate input, it also allocates the memory location associated with that value. So amount will receive a value, rate will receive a value, and here we use them in this computation. We did, however, need to store it as a tax, which we didn't have defined. So we defined a variable called tax up here that is assigned the product of amount and rate. And then finally, as usual, we just write out the answer. And here we can see sample output coming out. Okay, so we know that when we use compute tax, we're going to have to pass in two arguments corresponding to these two parameters. So let's see how we've used it. Sub main is going to go after the balance and the rate from the user. So here we see some variables associated with getting the balance and the rate, as well as corresponding string variables. We're going to read them in as strings first and convert them to doubles, which is exactly what these next four statements do. We're getting the balance and rate from the user and assigning them to local variables balance and rate that we've defined. Here comes the call to compute tax. One thing to note is when we pass in arguments, we never pass in the data type. So notice there's no as double, by-val, or any of that syntax. We very simply put what it is we're trying to pass. And if we have multiple pieces of data, we separate them by a comma. So we wanted to share the balance and the rate. So that's what we've done here. We've said, okay, we're passing in the balance, we're passing in the rate. Now it does turn out that the order of these arguments is important because they will be matched up in the same order to their parameters. So in other words, we wanted the balance, whatever that is, to be, let's say, $50. We wanted the balance to be passed into the parameter amount. Remember, these names don't need to be matched up. Instead, the value of 50 will be copied into amount. We wanted the rate that was entered by the user, let's say 0.045, to be passed into this parameter named rate. So for that to happen, we had to place the arguments in the same order as the parameters in which we wanted them to be matched to. So this calls compute tax, passes the values as indicated by the user, comes down into compute tax, declares tax, calculates it, and outputs it. So we could go back to our example here. Let me uncomment the name and say, let me go back to our original example here, name. Say that in addition to greeting the user, we wanted to pass in a piece of punctuation to say, hello, Gina, with an exclamation point, or hello, Gina, with a period, or whatever punctuation we wanted to be appended to the end of the message. We could do that. We could pass that as an argument to output hello. Again, adding a second argument up here immediately causes a problem because it says that this output hello procedure only receives one parameter. So therefore, to fix that, I'm going to add a second parameter here, call it punctuation. And that punctuation parameter is going to be used to receive my argument that I'm passing in here. Now I happen to pick an exclamation mark, but I could have picked a comma or anything else really. And that's what I'm going to use I did put an extra space in between. Actually, I take that back. I do not want a space before punctuation there. After the name, I would like to see the punctuation. So for example, going back to Gina, if the user input their value of Gina, then here I'm calling output name and passing Gina and an exclamation mark. I did not ask the user for punctuation. I just hard-coded it to an exclamation point. If I wanted to make this a different program, I could have used a variable with punctuation, but I just used the literal exclamation point. Name will be passed into name down here because the first argument is passed to the first parameter. The second argument here, exclamation mark, will be passed to the second parameter. So here, this is going to concatenate all of this together. Hello, Gina, exclamation point. So let's go ahead and run this. I know I keep saying Gina, but I'll go back to my name, Sharon, and we get our message, hello, Sharon. So that was just a really simple example of passing two arguments into two parameters. So we're defining a sub-procedure with multiple parameters.